Far below the surface of our planet, hidden within rock layers older than humanity itself, scientists have uncovered mysteries that defy explanation. Microscopic spheres of rare metals, carbon isotopes that don't belong, traces of chemicals that resemble the byproducts of industry, yet date back millions of years before humans ever walked the Earth. What if we are not the first civilization to rise on this planet? What if long before the pyramids, long before the dinosaurs, even before mammals took their place on the evolutionary stage, Earth was home to another intelligence, a species capable of shaping the world, building technology, and leaving behind fingerprints that still whisper through time? This is the Silurian Hypothesis, the daring scientific question of whether an industrial civilization could have existed long before humans. And if so, what evidence would it leave behind? If you like the content, like and subscribe to the channel as we start this incredible journey. We humans like to imagine ourselves as the pinnacle of creation. Unique, special, the first. When we look at our world, the shining skyscrapers of our cities, the satellites circling silently above the Earth, the deep-sea cables connecting continents, we feel a kind of pride. Surely, no one before us could have achieved such wonders. Surely, we are the first to take this planet and bend it to our will. But the Earth itself tells a different story. Our planet is unimaginably old, 4.5 billion years old. To say that number is one thing, to really grasp it is another. The human brain struggles with scales of time so immense that millions of years feel almost the same as billions. We can say the words, but can we feel their weight? So, let's try an experiment. Imagine taking all of Earth's history, every volcanic eruption, every creature that ever swam, every tree that ever grew, and compressing it into a single calendar year. January 1st would be the birth of the Earth, when dust and rock in the young solar system came together to form this blue sphere. On that calendar, life itself, simple, microscopic, fragile, wouldn't appear until March. Complex cells with nuclei arrive around September. In late November, the oceans fill with creatures we'd recognize as animals. Dinosaurs stride into the picture in December, ruling the world for more than 3 glorious weeks. And then in the final hours of New Year's Eve, mammals begin to rise, flowers bloom, and the Earth becomes a place vaguely familiar. Modern humans, we appear at 20 minutes to midnight on December 31st. All of recorded history, from the pharaohs to the pyramids, from Caesar to Shakespeare, from Galileo to moon landings, unfolds in the final seconds before the clock strikes 12. That is how tiny our place really is. A flicker of fire in a dark, endless night. And here's the unsettling thought. If another advanced civilization had risen and fallen, not in the last few thousand years, but 50 million years ago, or 100 million, or even 300 million years ago, would we even know? To answer that, let's do something uncomfortable. Let's imagine a future where we are gone. Imagine that tomorrow humanity disappears. Not with a bang, not with a world-ending war, but simply gone. What happens to the traces of our world then? In a decade, nature begins to claw back what was hers. Vines wrap around forgotten houses. Animals creep through the empty streets. Wolves stalk the highways. Birds nest inside broken windows. In 100 years, almost every building collapses. Roofs cave in. Glass shatters. Bridges tumble. The skeletons of our cities stand briefly, then fall. 1,000 years later, even the strongest monuments are crumbling. The Eiffel Tower has rusted away. The Statue of Liberty lies broken in the harbor. The tallest skyscrapers have collapsed into piles of rubble. Only a handful of stone giants remain. The pyramids of Giza, the Great Wall of China, Mount Rushmore. But even these are eroded, battered shadows of their former glory. Leap forward 100,000 years, and entire ice ages have swept across the continents. Glaciers grind the surface like sandpaper, scraping away roads and burying whole cities under mountains of ice. Forests rise, burn, and rise again. Deserts shift, burying the traces of human life beneath dunes. 10 million years later, mountain ranges have risen and been ground down to dust. Rivers have carved new paths, swallowing valleys whole. Volcanoes have spilled lava across ancient landscapes. Oceans have risen and swallowed coastlines only to retreat again. What chance does a city have against such relentless forces? Practically none. Geology is the great eraser. It is patient, merciless, and thorough. So then what of us? What of our story? What would remain for some far future intelligence to find? Not our monuments, not our cities, not the great machines of industry. What would remain our fingerprints, faint but telling? A thin line in the rocks, a chemical scar, traces of carbon from our burning of fossil fuels. Plastic particles transformed by pressure into strange new rock-like substances. Unnatural isotopes, the ghostly reminder of our nuclear experiments. Perhaps a fossil here or there, one human skeleton, a cow, a dog, if they were lucky enough to be buried in just the right conditions. And that's all. Billions of lives, entire empires, countless triumphs and tragedies, all reduced to a layer of dust and chemical residue, a whisper in the stone. And if this is true for us, if we with our global cities and world-spanning technologies could disappear so completely, then we are forced to ask a question that chills the blood. What if it has happened before? What if another species, not human but something entirely different, rose to intelligence long before us? What if they too built their world, discovered energy, created technology only to vanish into silence? Would we recognize the signs, or would we dismiss their fingerprints as natural quirks, just as we almost dismissed our own warming climate as a simple cycle of the Earth? This thought is not as far-fetched as it seems. Consider the dinosaurs. They ruled the Earth for more than 160 million years. That's over 800 times longer than humans have existed. And yet, what remains of them? Bones, teeth, footprints pressed into stone, a few chemical traces. That is all. If hidden somewhere in that immense span of time, an intelligent branch of dinosaurs had risen to build cities, what would we see of them 65 million years later? Almost nothing, perhaps not even enough to prove they were real. Absence of evidence is not evidence of absence. That phrase has become a cliché, but here it may be the most important truth of all. Just because we have not yet found proof of another civilization does not mean there was none. It means only that the Earth is a poor archivist. Its records are scattered, its memory fragmented, its history rewritten again and again by fire and ice and time. This is the humbling realization at the heart of the Silurian Hypothesis. Our story may not be the first. We may only be the most recent chapter in a saga that has played out again and again. Civilizations rising and vanishing beneath the shifting skin of stone and time. And as outlandish as this may sound, it is not simply a tale for science fiction. It is a serious scientific thought experiment, one that forces us to rethink what civilization means, how fragile evidence really is, and whether Earth itself might be hiding secrets older than humanity. And so, we must ask the question that will guide us through this journey. If we are not the first, what traces should we look for? What clues could survive? And more importantly, are there already hints waiting in the rocks beneath our feet? The Silurian hypothesis begins, strangely enough, not in the fossil beds of a desert or the core samples of an ocean trench, but in the minds of two scientists who dared to ask a question most would laugh at. In 2018, astrophysicist Adam Frank and climate scientist Gavin Schmidt published a paper in the International Journal of Astrobiology. At first glance, the title seems straightforward: the Silurian Hypothesis. Would it be possible to detect an industrial civilization in the geological record? But hidden within those words was a question bold enough to rattle the way we see ourselves. They weren't claiming there was an ancient civilization. They weren't saying dinosaurs built cities or that some forgotten species once had technology. What they asked was far more subtle and in many ways more disturbing. If such a civilization had existed millions of years ago, how would we know? That single question flips the burden of proof. Normally, scientists dismiss wild claims with the phrase, "Extraordinary claims require extraordinary evidence." But Frank and Schmidt turned it around. If evidence is so fragile, what if even an extraordinary civilization could vanish without leaving a trace? The very name of the hypothesis carried a wink and a nod. They called it Silurian after a species in the long-running science fiction series Doctor Who. In that story, the Silurians are an ancient reptilian race who thrived long before humans, retreating underground to hibernate while mammals took over the Earth. When they awaken millions of years later, they find themselves face to face with us, the newcomers. Frank and Schmidt weren't claiming reptilian overlords were real, but the metaphor was perfect. Science fiction had already played with the idea of civilizations before our own. What they did was strip away the fantasy and treat the question with sober seriousness. And the more they looked at it, the more troubling the answer became. First, the idea sounds absurd. If there had been an industrial civilization millions of years ago, surely we'd have found ruins, tools, bones, or fossils. Surely something would remain. But science is about testing assumptions. And when you test this one, it begins to crack. Frank and Schmidt argued that when we look at Earth's geological record, it is full of gaps. Whole continents worth of rock have been ground down and subducted into the mantle. Oceans are constantly recycling their crust, erasing millions of years at a time. Fossils are incredibly rare. Only a vanishing fraction of life ever makes it into stone. And the more time passes, the rarer that preservation becomes. So the real question is not would we have found ruins, but what kind of evidence could possibly survive tens of millions of years? And their answer was sobering. Very little. Almost everything we think of as civilization, buildings, machines, even bones would be gone. What might remain are the indirect signatures, the fingerprints of industry, strange isotope ratios in the soil, carbon anomalies in the atmosphere, layers of unusual materials like plastics or synthetic compounds, perhaps in the rarest cases, a fossilized artifact preserved under perfect conditions. But mostly what we'd be left with are the kinds of signals we're creating right now. A sudden sharp chemical shift in the planet's surface, detectable millions of years later by some future intelligence digging into the rock. To illustrate their point, Frank and Schmidt proposed a reversal of perspective. Imagine, they said, that an alien scientist came to Earth 100 million years in the future. What would they find of us? Would they see the outlines of cities? No. Would they find intact machines? Not a chance. Would they dig up human bones by the millions? Almost certainly not. But what they would notice is that at a certain point in the rock layers, the carbon cycle of the planet shifted abruptly. They would see traces of fossil fuel burning, massive climate warming, and extinctions clustering together. They might find rare isotopes left behind from nuclear weapons. They might even stumble across compressed layers of plastic transformed into a kind of technofossil stone. To that alien scientist, it would look as though some brief but intense industrial phase had occurred. An industrial spike that lasted maybe a few centuries or millennia followed by collapse. Now turn the thought experiment around. If we saw such a spike in Earth's past, would we immediately think, "Ah, an ancient civilization"? Or would we search for natural explanations, volcanoes, asteroid impacts, methane releases? Frank and Schmidt believed the latter, and that is precisely the problem. Even if we did stumble on a geological scar left by another species' industry, we might never recognize it for what it was. It's easy to laugh at the idea of lost civilizations. After all, human history has its share of conspiracy theories. Atlantis' ancient aliens, supposed out-of-place artifacts that claim to rewrite prehistory. Serious scientists avoid these subjects, not wanting to be lumped in with pseudoscience. But the Silurian hypothesis is different. It doesn't start with fringe claims. It doesn't start with a supposed artifact or mystery ruins. It starts with a serious scientific puzzle. How much of our own civilization would survive in the deep geological record? By framing the question this way, Frank and Schmidt weren't endorsing wild claims. They were creating a thought experiment, a lens through which to view both our own impact and the limitations of geology. And perhaps most unsettling of all, their conclusion was that it would be very, very hard to rule out the possibility of civilizations before us. To understand why this resonates, look not at deep time, but at our own shallow history. Human civilization is only a few thousand years old, and yet we have already lost whole chapters of it. Think of the Indus Valley civilization, once one of the great powers of the ancient world with cities, plumbing, and a written script. It flourished for centuries, then collapsed. Today, most people barely know it existed, and much of its language remains undeciphered. Or take the Maya. At their height, they built monumental cities in the jungles of Central America. When their civilization declined, the rainforests swallowed their temples so completely that Europeans arriving centuries later had no idea they were there. Even closer to our time, consider the Library of Alexandria, a treasure trove of ancient knowledge, lost in fire. Entire books, philosophies, sciences, gone forever, their contents unknown to us. These are losses across centuries and millennia. If civilizations can vanish almost without a trace in a few thousand years, how much harder would it be to detect one from 100 million years ago? Some might wonder, why name it after a fictional species? Isn't that unscientific? In fact, the choice was deliberate. By using a name from science fiction, Frank and Schmidt acknowledged the strangeness of the idea while disarming critics. It was a way of saying, we know this sounds wild, but let's treat it with rigor anyway. And that balance between playful imagination and serious inquiry are what makes the hypothesis so powerful. It forces us to confront uncomfortable truths, not just about the possibility of ancient civilizations, but about the fragility of our own. The real brilliance of the Silurian hypothesis is not in whether it proves another civilization existed. It's that it opens the door to deeper questions. How do we define civilization? Is it skyscrapers and satellites, or is it the chemical imprint we leave behind? How long does intelligence last on a planet before it consumes itself? Could other worlds we explore, Mars, Venus, even exoplanets, bear similar signatures of civilizations that came and went? By asking whether we could detect one here, Frank and Schmidt created a framework for looking everywhere. And perhaps hidden in that framework is a quiet warning. If the only thing left of us millions of years from now is a thin scar of carbon, plastic, and radioactive dust, then maybe that is the fate of civilizations everywhere. Brief, brilliant, and fleeting, the Silurian hypothesis began as a playful nod to science fiction. But beneath that playful exterior is a deeply serious question. One that challenges our assumptions about time, about evidence, and about the uniqueness of humanity. If we could vanish without a trace, then maybe, just maybe, someone else already has. To understand why the Silurian hypothesis carries weight, we first need to confront the scale of geological time. It is the vast canvas upon which Earth's story has been painted. A canvas so immense that even the entirety of human civilization barely registers as a brushstroke. Most people think in centuries. Some can stretch their imagination to thousands of years back to the pyramids or the earliest recorded history. A few might reach tens of thousands, imagining the last ice age or the cave painters of Europe. But to grasp geological time, we must think not in thousands, but in millions and billions. The Earth is 4.5 billion years old. Over that staggering expanse, continents have drifted, oceans have opened and closed, mountains have risen and crumbled, climates have swung from frozen snowball states to sweltering greenhouse. Life itself has gone through repeated revolutions, flourishing, collapsing, and reinventing itself anew. Against this backdrop, modern humanity, cities, science, technology has existed for less than 10,000 years. A fraction so small that if Earth's history were compressed into a single calendar year, all of recorded civilization would occur in the final 30 seconds before midnight on December 31st. That perspective is humbling, but it is also dangerous because it blinds us to the depths of time where secrets could be hidden. Let us imagine for a moment that we buried a city today, New York, Tokyo, or London, under tons of rock and sediment. What would remain in 10 million years? In the short term, skyscrapers would collapse. Steel would corrode, concrete would crumble, glass would shatter. Within a few centuries, nature would reclaim everything. Forests, rivers, and soil would erase the surface, covering the ruins in layers of sediment. Within a few million years, tectonic pressures would compress those layers into stone, scattering fragments of human construction like pebbles lost in a gravel bed. By the time 10 million years had passed, the surface evidence would be almost entirely gone. Only in rare conditions such as rapid burial by volcanic ash or preservation in an anoxic seabed would fragments survive as fossils of technology. And even then, the odds of them being uncovered in the far future would be vanishingly small. Now extend this thought experiment. What about 100 million years? By then, the continents would have shifted. Mountain ranges would have eroded away and ocean floors would have been recycled into the mantle. Almost no surface trace of our civilization would remain. If that sounds unbelievable, consider this. We live on a planet that has been home to countless empires of life before us. And yet, their traces are often astonishingly faint. Dinosaurs ruled the Earth for 165 million years. Over 16,000 times longer than recorded human civilization has lasted. And yet, what remains of them? A scattering of fossils, some footprints, a few impressions of skin and feathers. Out of the billions upon billions of dinosaurs that lived, only a tiny fraction ever fossilized. Most vanished without a trace. Their bones eroded, their bodies consumed, their existence erased. For all their dominance, for all their immense time span, the story we reconstruct of them is based on scraps, whispers preserved by chance. If creatures as vast, numerous, and long-lived as the dinosaurs left so little, what chance would a short-lived technological species have? The fossil record is biased toward the rare and the lucky. Hard shells fossilize better than soft bodies. Creatures near riverbeds, lakes, or deltas fossilize more often than those on open plains. Entire ecosystems can vanish without leaving behind a single fossil, as if they never existed at all. This is why paleontology is a science of fragments of puzzles with missing pieces. The deeper we go in time, the more pieces are missing. Geological time is not a perfect archive. It is more like a palmist, a manuscript that has been written, erased, and overwritten countless times. Sediments build up only to be lifted and eroded away. Rock layers are folded, faulted, melted, or subducted. The surface of the Earth is constantly rewritten. This means that even dramatic events, mass extinctions, asteroid impacts, supervolcanoes often leave subtle signatures. The asteroid that ended the Cretaceous period 66 million years ago, wiping out most dinosaurs, left only a thin layer of iridium-rich clay visible in scattered locations around the globe. Without that layer, without a few shocked minerals and a buried crater in Mexico, we might never have known it happened. Now, imagine trying to detect something subtler like a brief industrial civilization that lasted only a few tens of thousands of years. Against the backdrop of hundreds of millions, it would be no more than a geological heartbeat. Its signals could be faint, localized, or erased altogether. Another difficulty is how deep time compresses events. When we look at a rock core, we might see a few cm of sediment representing thousands of years. In older strait, a few cm might represent hundreds of thousands or even millions. Events that felt long and dramatic to the beings living them can appear as razor-thin layers to us. For example, the Paleocene thermal maximum, a sudden warming event 56 million years ago, lasted around 200,000 years. To humans, that would be unimaginably long. Yet, in the rock record, it appears as a narrow band of chemical shifts, one that could easily be overlooked without careful study. If an industrial civilization had existed, then its entire rise and fall could be compressed into that same band, indistinguishable from natural climate variation. Unless we knew what to look for, we might never suspect it was anything but geology at work. There is also the matter of our own perception. Humans are not wired to think in deep time. We evolved to survive days, seasons, maybe decades. The lifespan of a tree can already feel eternal to us, let alone the lifespan of a mountain or a continent. When scientists describe millions of years, we nod our heads, but we rarely internalize what that truly means. We treat a million years ago and a 100 million years ago almost as if they were the same, just a long time. But in reality, the difference is staggering. A million years ago, early humans already roamed the earth. 100 million years ago, our ancestors were tiny mammals scurrying in the shadows of dinosaurs. This flattening of time in our imagination makes it easy to dismiss the possibility of hidden histories. If we struggle to grasp the sheer scale, we underestimate how easily civilizations, even powerful ones, could be buried and forgotten. Here lies the paradox. On one hand, human civilization feels so overwhelming, so permanent. Our cities, satellites, and industries seem impossible to erase. On the other hand, when viewed through the lens of geological time, we are fragile, fleeting, and almost invisible. Both are true. In the short term, our impact is colossal. In the long term, the Earth is merciless in its ability to erase. This paradox is at the heart of the Silurian Hypothesis. It reminds us that what feels eternal to us is temporary to the planet, that our records are monuments. Our very bones could vanish, leaving only the faintest scars for some future intelligence to puzzle over. And so we arrive at the unsettling possibility that the Earth may have hosted other stories, other civilizations long before ours. If they were short-lived, if they rose and fell in the span of a few tens of thousands of years, then deep time would swallow them whole. We assume we are the first. We assume intelligence is rare. But those assumptions rest on evidence that is by the nature of geology incomplete. The truth is, the further back we look, the less certain we can be. Our blind spot is not just ignorance. It is structural. The very processes that shape Earth also erase its memory. What we see is not the full story, but a heavily redacted version. And in those redactions, who knows what chapters have been lost? If we are not the first civilization to have risen on Earth, then the ruins of our predecessors will not present themselves as stone cities preserved beneath the sands or fossilized machines waiting in caves. No, the Earth is too cruel a keeper for that. Its surface is restless, endlessly reshaping itself through the slow violence of erosion, volcanism, and tectonic drift. Whatever once stood upon it is eventually dragged down into the furnace of the mantle or worn away into dust. What remains are not monuments, but fingerprints, subtle scars left in the rocks and soils, chemical echoes of choices once made, faint anomalies that speak of something that should not have been there. If we are to search for forgotten civilizations, we must learn to read these scars and to ask ourselves a question both unsettling and thrilling. If an industrial civilization existed long before us, what traces would it leave? The clearest clue is carbon. We burn ancient fossil fuels, releasing CO2 that warms the planet and alters carbon's isotopic balance. Our age will show up as a sharp, global shift in carbon ratios, the Seuss effect, permanently recorded in rock. But similar anomalies already exist in Earth's history. 56 million years ago, during the Paleocene-Eocene thermal maximum, global temperatures spiked and oceans acidified. The carbon shift looks almost identical to ours. Its cause remains uncertain. Volcanism, methane release, or something we haven't considered. Go back 250 million years to the end Permian extinction, the worst in history. Over 90% of marine life vanished. Massive greenhouse gas release is blamed, but the chemical signal resembles industry on an unimaginable scale. If we didn't assume industry was impossible, would we interpret the rocks differently? Another unmistakable marker: plastic. In only decades, it has coated the planet, drifting in oceans, buried in sediments, becoming fossil plastic rock. Future geologists would instantly recognize it as artificial. Could we already have overlooked such odd layers from deep time? Metals tell a similar story. Pure aluminum, titanium, rare earths. Unnatural concentrations of refined metals would persist and puzzle future scientists. Mines, quarries, and massive land reshaping would leave strange geological scars. Even agriculture leaves a pollen signature marking the disappearance of forests. Then comes the nuclear shadow. Human detonations scattered artificial isotopes worldwide. Even in 10,000 years, a thin radioactive layer will remain, a global sign of intelligence. Yet if we found such isotopes in ancient rocks, would we accept a technological cause? Natural nuclear reactors once existed, proving how easily evidence can be misread. And finally, extinction. Industry drives a rapid collapse of biodiversity, the sixth mass extinction. The fossil record will show a sudden loss of species, much like previous mass extinctions we attribute to volcanoes or impacts. But what if one of those past events wasn't natural? The paradox. Industrial fingerprints, carbon shifts, plastics, metals, isotopes, extinctions are real and permanent, but none are exclusive to civilization. Nature produces similar scars. What we see as obvious signs of industry might look natural to future scientists, just as ancient anomalies might hide intelligent origins we never considered. If humanity vanished tomorrow, the evidence of our existence would remain. But the deeper into time we look, the more the Earth erases. Entire chapters could be missing. This is the heart of the Silurian hypothesis. It's not that ancient civilizations definitely existed. It's that we can't be sure they didn't. The fingerprints we'd expect are already there. The question is how we choose to interpret them. Are these clues the result of geology alone, or whispers of something older and forgotten? In the end, the warning remains. Someday we too will fade. Our cities will crumble. Our languages vanish. What endures is chemistry, carbon scars, plastic fossils, radioactive dust. If others came before, perhaps they are remembered only the same way. History is scattered with puzzles that challenge our timeline, objects and structures that don't belong. A hammer sealed in stone, metal fragments found in ancient coal, geometric patterns on the seafloor. Science often dismisses them as mistakes or coincidences, yet the questions linger, forming a shadow history beneath the official one. Out-of-place artifacts push this further. The London hammer, a modern tool trapped in rock millions of years old, explained as a natural concretion, yet still unsettling. Tiny metallic spirals found in Russia, resembling machine parts, dismissed as drilling debris, but their mystery persists. Coal seams have reportedly yielded nails and chains far older than humanity. Likely contamination, but imagination refuses to let go. Sometimes it's landscapes that seem artificial. The submerged Yonaguni structure appears carved, steps and terraces plunging into the sea. Natural fracturing, experts say. Yet standing on its ledges, doubt remains. Massive stones at Baalbek, precisely carved and impossibly heavy, credited to Romans, but some suspect they inherited far older foundations. Even maps raise eyebrows. The Pyrie Reis map may show an ice-free Antarctica, possibly a distortion of earlier charts, or a faint echo of knowledge from a forgotten age. Geology itself holds strange signals. Metallic microspherules at major extinction boundaries, usually tied to impacts or volcanism. But modern industry creates identical byproducts that will confuse future scientists. Could some ancient layers reflect furnaces rather than fire from space? Then come the myths, golden ages, civilizing gods, world-flooding cataclysms told across distant cultures. Archetypes, say scholars, or fractured memories of something real, passed through millennia until only legend survived. Mainstream explanations for every anomaly are reasonable. Rapid mineralization, natural fracturing, misreported finds, shared storytelling patterns. And yet, anomalies persist. They press on the boundaries of our certainty. If a civilization rose millions of years ago, time would erase nearly all of it. Machines and buildings would vanish. Only rare puzzles, a manufactured fragment, a suspicious stone would remain. And those are exactly the kinds of puzzles we find. This is the unsettling point of the Silurian hypothesis. Even if ancient civilizations existed, the evidence would look almost exactly like the anomalies we already have, and like natural processes we already assume. We are forced to confront a deeper question. How well does Earth remember? If our own industrial age could be lost so easily, how much of the planet's past has already slipped into silence? Every anomaly, whether solved or not, reminds us Earth's history is not complete, just heavily edited. Much has been erased, and we may not be the first to leave fingerprints behind. Are these marks of geology alone, or echoes of something older? In the end, the message remains: we too will become whispers. Our cities erased, our culture forgotten. What survives are chemical fingerprints, plastics, carbon scars, radioactive traces. The Earth remembers through chemistry, not monuments. And if another civilization once walked this world, they may be remembered the same way. Across centuries, strange discoveries have challenged our timeline, objects found where they should not be. A metal hammer sealed in stone, coils pulled from ancient sediments, patterns on the seafloor that seem too precise to be natural. Most are explained and dismissed. Yet the questions linger, forming a shadow history beneath our own. Opart's out-of-place artifacts fuel these doubts. The London hammer encased in rock that seems impossibly old. Metallic spirals in Russia, tiny machine-like coils found in layers dated far earlier than industry. Nails or chains reported inside coal tens of millions of years old. Each claim faces logical rebuttal. Contamination, modern debris, geology playing tricks. But imagination refuses to let them go. Not all anomalies are objects, some are entire landscapes. Off Japan's coast, the Yonaguni formations resemble steps and terraces, debated as natural fractures or a sunken monument. The megaliths of Baalbek appear beyond even Roman engineering, suggesting inherited knowledge from a forgotten age. And if so much can vanish in just a few thousand years, what about a million? Maps too raise eyebrows. The Pyrie Reis map seems to show Antarctica ice-free, implying a lost source of ancient geographical knowledge. Could fragments of a vanished world survive only as copies of copies, stripped of origin? Even geology leaves curious signatures. Metal spherules scattered through ancient layers mirror the industrial fallout we produce today. Future scientists will see them as evidence of us, proof of technology. Could similar traces from deep time already exist, misunderstood as natural? Mythology adds another thread. Stories of golden ages, devastating floods, gods from the sky. Skeptics see universal symbolism. Others suspect dim memories of real catastrophes and civilizations erased so completely that only myth endured. Science offers valid explanations for each anomaly, yet their persistence keeps uncertainty alive. If a civilization rose millions of years ago, nearly all direct evidence would be gone. A few odd artifacts or patterns in stone are exactly what we'd expect to remain. That is the unsettling point behind the Silurian hypothesis. Not that ancient advanced cultures definitely existed, only that if they did, the traces would look very much like the anomalies we already find. It challenges us to question how well we truly know Earth's memory. Geology swallows history. Every unexplained fragment is a reminder that our story is incomplete. Its pages torn, its margins smudged, its secrets largely erased by time. If a major asteroid struck today, our cities would fall and our systems collapse. A supervolcano could darken the sun for years. These disasters have happened and will again. We cannot stop them. At best, we endure. But the greatest dangers may be the ones we create: AI beyond our control, engineered plagues, self-replicating machines. Every new technology is a match in a dry forest. One failure could end us. So what must we learn? First, humility. We are not guaranteed. We are fragile. Second, foresight. We must think in millennia, not election cycles. Third, stewardship. We survive only if the planet stays livable. There is hope. We alone can plan ahead. We can deflect asteroids, track volcanoes, stabilize climate, and learn from the history of life itself. And we must look beyond Earth. As long as we are confined to one world, we remain vulnerable. The dinosaurs had no space program, so they are gone. To endure, intelligence must spread outward. In this light, the Silurian hypothesis becomes a warning. If others once rose and fell, why did they vanish? Even without proof, Imagining them forces us to confront our fragility. Millions of years from now, another species may find the chemical ghosts of our existence: carbon spikes, plastic stones, radioactive traces, and wonder, did they see their fate coming? Did they try to survive? We can only hope they learn we did not disappear. We evolved, expanded, and endured. Survival is not owed to us. We must earn it generation by generation. If we fail, we are forgotten. If we succeed, we become the first species to defeat extinction, to carry the story of intelligence across deep time. But to prove a civilization before us existed, we would need evidence that cannot be erased by geology. That means searching in the places Earth hides its history. Ruins crumble, mountains fall, continents drift. Almost nothing human-made would survive millions of years. To find deep-time intelligence, we must look at chemistry itself, the isotopic scars in rock. Burn enough fuel and carbon fingerprints remain. Industrial metals collect in layers. Plastics fuse into stone. Radiation leaves tracks in the soil. If such clues exist in ancient strata, what would they mean? Even bones, if they ever existed, would be dust. So scientists widen the search to Mars, Venus, and distant moons, where time preserves far better than on Earth, and to exoplanets, where we look for technosignatures in alien skies. Skeptics argue Earth erases too well, that anomalies will always have natural explanations. And they may be right, but the search sharpens science. It reveals how profoundly we are already altering the planet. We are the unnatural carbon spike. We are the plastic layer. We are the radioactive line in the rock. We are the anomaly future beings might find. In looking for others, we discover ourselves. Throughout history, colossal eruptions have poured fire into the sky and ash across the world. The Siberian traps, for instance, erupted around 252 million years ago in an event so massive it covered an area larger than modern Europe with layers of basalt rock. For nearly 1 million years, volcanoes belched carbon dioxide and sulfur into the atmosphere, triggering runaway greenhouse warming, acid rain, and the collapse of ecosystems. The Permian Triassic extinction, which followed, wiped out around 90% of all species in the rocks. This looks like an abrupt global chemical shift. If we didn't know about volcanism, we might imagine an industrial civilization pumping greenhouse gases into the air. In truth, nature itself can outdo even our most ambitious pollution. Asteroid impacts are another explanation for strange signatures in the geological record. The most famous example is the Chicxulub impact, the 6M-wide asteroid that struck Earth 66 million years ago and ended the reign of the dinosaurs. The force of the collision released the energy of billions of nuclear bombs, vaporizing rock, igniting global wildfires, and plunging the planet into darkness. Across the world, rocks from that time contain a thin layer enriched with iridium, a metal rare in Earth's crust, but common in asteroids. They also contain tiny glassy spirals, droplets of molten rock blasted into the sky and cooled as they fell. To a geologist millions of years in the future, such a layer might look eerily like the debris of a nuclear war. Yet in this case, it was not civilization but blind cosmic chance that scarred the Earth. There are also events that look suspiciously industrial but have purely biological origins. The Great Oxidation Event more than 2 billion years ago transformed Earth's atmosphere from a world without oxygen into one rich with it. Tiny microbes capable of photosynthesis multiplied across the planet, releasing oxygen as waste to the rocks. This was a sudden, dramatic chemical shift. Iron rusted in oceans, leaving vast deposits of banded iron stone. Methane was destroyed in the air, plunging the Earth into a series of ice ages. If a geologist from another world studied those rocks, they might think an advanced civilization had deliberately terraformed the planet. In truth, it was the slow, relentless work of bacteria. Even more recently, natural cycles can create anomalies that look artificial. Sudden climate changes have left sharp lines in ice cores and sediments. Natural fission reactors like the one discovered at Oklo in Gabon, Africa, can mimic the byproducts of nuclear technology. But the fact that we know natural processes can create such signatures don't erase the possibility that technological ones could as well. And so the debate circles around two poles: the extraordinary possibility of ancient intelligence and the extraordinary power of natural Earth. One asks us to dream of civilizations older than humanity. The other reminds us of a planet capable of producing wonders and disasters without help from any mind at all. Science demands that we explore both, weighing the evidence carefully, resisting the lure of easy answers. This is where the Silurian hypothesis becomes less about proving ancient civilizations and more about refining our own understanding of Earth by treating every anomaly as a potential technosignature. We test our assumptions. We build sharper tools. We expand our knowledge of volcanism, of impacts, of microbial revolutions, of the cycles that make and unmake worlds. Whether or not an ancient civilization truly existed, the hunt for one makes us better scientists, more careful readers of the planet's history. And perhaps that is the point. Perhaps the Earth's great story is already strange enough, already alien enough without inventing lost civilizations to explain it. Perhaps the real lesson is that intelligence, whether it arises once or many times, always leaves a mark, and that the Earth in its endless creativity will always keep us guessing. The Silurian hypothesis may be about imagined civilizations buried in deep time, but its most unsettling lesson is not about them. It is about us. When we ask whether Earth has hosted other intelligent species before, we are really asking what traces intelligence leaves behind, how long those traces endure, and whether we ourselves are destined to vanish into the same silence. Our civilization feels enormous. We dominate landscapes, reroute rivers, dig into the crust, release carbon by the billions of tons, scatter satellites into orbit, and send probes beyond the edge of the solar system. From our perspective, we are titans. Yet measured against the scale of geological time, we are a flicker. The first Homo sapiens walked the Earth less than 300,000 years ago. Our cities are barely 10,000 years old. Our fossil fuels, the engines of modern industry, may last only a few more centuries at current rates of use. If we vanish tomorrow, in 1,000,000 years, most of our monuments would be gone. In 10 million, our cities would be buried, our metals corroded, our books and digital archives reduced to dust. Only the most stubborn chemical traces, the plastics, the isotopes, the scars in the carbon cycle might whisper our existence. This realization is humbling. It tells us that dominance is not permanence. If there were other civilizations, their time was short, their memory erased. If there were none, it may be because intelligence itself is fragile, rising rarely and vanishing quickly. Either way, the question becomes urgent. What will happen to us? Will we too be just another thin layer in the rocks? Climate change sharpens this question. When we examine past anomalies like the Paleocene thermal maximum, we see a world heated by greenhouse gases, oceans acidifying, species struggling to survive. It took the Earth more than 100,000 years to stabilize. Today, we are creating similar conditions in centuries. If an earlier civilization once triggered such a crisis, they may not have survived it. Are we walking the same path, rushing toward a cliff we cannot yet see? Mass extinction is another sobering parallel. Earth's history is marked by 5 great extinctions, each erasing the majority of life and reshaping the planet's future. Many of these were caused by natural disasters, volcanoes, asteroids, runaway climate shifts. But today, we are the asteroid. Our industries, our deforestation, our fishing fleets, our carbon emissions are driving species to extinction at rates unseen in millions of years. If a future geologist were to study our time, they would see a great dying. If another civilization did the same in their own age, we might never know. Extinction erases both the weak and the wise. But the Silurian Hypothesis offers more than warnings. It also offers perspective. By asking what traces we leave behind, we learn to see ourselves as part of the Earth's story, not above it. We see that the Earth does not remember in monuments, but in chemistry. Our skyscrapers may not endure, but our plastics will. Our nuclear waste will, our carbon will. When we imagine another civilization's traces, we are imagining what our own will look like. And perhaps this is the deepest implication. We are writing our obituary in stone right now. Every barrel of oil burned, every reactor split, every acre of rainforest cleared becomes part of that geological story. The Earth will carry our mark whether or not anyone is left to read it. There is also a strange comfort in this. Civilizations may rise and fall, but life endures. After every extinction, the Earth blooms again. New species evolve. New ecologies form. New possibilities open. Even if we do not endure forever, we are part of that vast cycle. Perhaps intelligence will rise again in 1 million or 10 million years among creatures we cannot imagine. Perhaps they too will wonder if they were first. And perhaps they too will find the traces we leave behind and draw their own conclusions. Yet this raises a choice. Knowing that civilizations can be fragile, knowing that time erases nearly all. Do we resign ourselves to disappearance? Or do we fight for endurance? If we are the first civilization, perhaps we are also the only chance intelligence has on this world. If we fail, there may not be another. The Silurian Hypothesis in this light is not just speculation but responsibility. It tells us that survival is not guaranteed, that our presence in the universe is rare and precious, and that the future depends on how we act in the present. We must also consider what traces we want to leave. Right now, our legacy is one of pollution, warming, and extinction. But could it be otherwise? Could we build a civilization that leaves behind not scars, but harmonies? An Anthropocene marked not by collapse, but by wisdom. That is the challenge before us. To learn from the Earth's past, whether or not it ever held other civilizations, and to choose a path that avoids their fate. The Silurian Hypothesis asks us to look back millions of years, but its real power is in how it makes us look forward. If intelligence is rare, then we are stewards of something cosmic. If civilizations vanish quickly, then ours must learn how to endure. The rocks will remember us, but the question is whether anyone else will. Will we be only a mystery in stone or a species that learned to outlast its own fragility? The answer lies not in the past, but in the choices we make now. Deep beneath our feet, the Earth holds a memory. It is a memory not written in books or carved into monuments, but pressed into stone, sealed into ice, scattered in the chemistry of oceans and skies. For billions of years, this planet has been writing its own story, layer upon layer, event upon event. Volcanoes, impacts, extinctions, births and blooms, all of it captured, all of it recorded. And yet, in that great geological library, one question remains unanswered. Are we the first to walk this path? or merely the latest chapter in a story far older than we imagine. The Silurian hypothesis does not give us proof. It offers us a mirror. By asking whether there might have been civilizations before us, it forces us to confront how fragile our own truly is. We like to think of ourselves as permanent, as inevitable as the culmination of evolution. But the rocks remind us otherwise. 99% of species that have ever lived are gone. Entire ecosystems have vanished, leaving only faint impressions in stone. Civilizations, if they arose before us, would likely have fallen the same way, leaving behind only chemistry, only scars, only mysteries that scientists millions of years later might puzzle over. Perhaps we are alone in our history. Perhaps Earth has seen no other intelligence before us. If so, the silence of the rocks is not comfort but weight. It means we are the first. It means we carry the responsibility not only of our own survival but of the entire legacy of thought, of reason, of imagination on this planet. If we fail, intelligence may never rise again. But perhaps we are not the first. Perhaps in some forgotten epoch, life took a different turn. Perhaps creatures we cannot picture. Reptilian architects, amphibian philosophers, insect engineers built worlds and watched them crumble. If so, then their absence is also a message. It tells us that intelligence does not guarantee survival, that progress does not guarantee permanence, that even the brightest civilizations can be swept away by catastrophe or undone by their own hand. And so we stand in the present looking both backward and forward. Behind us lies a vast and silent prehistory stretching into billions of years marked by mystery and erasure. Ahead of us lies an uncertain future where our fate will be written not by inevitability but by choice. We may vanish, becoming only a faint chemical anomaly in the rocks, or we may endure, carving out a legacy that stretches far beyond the lifespan of mountains and seas. The Silurian hypothesis asks us to hold both possibilities in our minds at once, to recognize that we may be unique or we may be repeating an ancient cycle, to accept that either way the responsibility is the same. We must care for the fragile world that birthed us. We must learn how to live not just for decades or centuries but for millennia. And we must leave behind traces not only of our power but of our wisdom. One day, millions of years from now, perhaps another intelligence will rise. They will dig into the rocks and find our lair. They will see the carbon, the plastics, the radioisotopes, the extinction we triggered. They will wonder what we were like. And maybe, just maybe, they will ask the same question we do now. Were they the first or just the latest? The Earth will not answer, keeps its secrets well. But in the silence of its stone, we can hear an echo, a reminder that civilizations are brief, that time is vast, and that the only way to endure is to choose a future worthy of being remembered. And that is the legacy of the Silurian hypothesis. Not proof of lost civilizations, but a challenge to the living, a challenge to us.